We are moving on to the second presentation. Our second speaker is Engineer Mohammed Al-Rashdi. Engineer Mohammed is Senior Planning Engineer at Muscat Electricity Distribution Company, and he will take us through a presentation on load forecast model in MEDC. It is an investigation and analysis of the current and future emerging low carbon technologies at MEDC. تفضل.
Assalamu alaikum. My name is Mohammed Al-Rashdi from MEDC. Today we'll talk about the investigation and analysis of low carbon technologies, the current status in Oman, in Muscat area, and the future forecast for this, and how much the impact on distribution network forecast. This presentation actually prepared by me, Mohammed Al-Rashdi, and my colleague Fatma Al-Gardani and Mohammed Shkeli. So let's start first with the load forecast. What the meaning of the load forecast? As you understand, the load forecast is the critical tool that we use to understand and forecast the demand for any distribution company for the next few years. It's very important and critical to understand the location and where exactly the growth of the distribution network. As you can see, for example, here, this is from last year. Okay, so this is from last year. We are right now in 2.4 gigawatt peak demand, and our customer account almost 400,000 right now currently, and we are expecting to grow to up to 3.1 gigawatt up to 2028. Of course, in any forecast model, we have to do it in three scenarios: base and high and low. And we are taking the worst case scenario. Of course, this diagram or this graph, we are doing it every year, and to understand the changes in the system and the distribution network. Now, what exactly the current process for doing any forecast model? There is a common inputs like customer account, energy consumption like RUD. Some GIS data, some SCADA data, and there is another information from MEDC database. And all this information actually are entered inside the model, and we get it using regression method right now we are using. There is like commonly around the world, there is two main method actually is using for forecasting the loads. Regression method and CGR or compound annual rate growth. Depend in the case which method use which method you can use for the load forecast. Currently, it's the best and the widely used is the regression methods. As you can see, for example, here in the blocks here, the first stages of any forecast model, we actually forecast the customer account and the energy consumption for the next few years, and also we are considering also the peak demand of the primary substation. With that, we include some other bulk loads and bulk applications is also important for us. And there is some other things like a load transfer, some losses, some information from the OETC from the grids also is considered is important. Now, what's new? The new things right now, the low carbon technologies, which actually we start hearing a lot about recently. So, what exactly low carbon technologies? Low carbon technologies is the technology that emit the low levels of CO2. There were actually a lot of technologies or actually emit the CO2. The most common things what actually we start seeing right now in the distribution network is these four: the electrical vehicle, distribution solar system, energy efficiency, and storage system, battery storage systems. Now, how actually these low carbon technology actually affect our distribution systems? How actually we assess the low carbon technologies and the effect on the distribution network? This is the main topic what inshallah we'll explain here. Now, for the solar system, as you understand, as you can see, there is a lot of multiple, request and connection of the solar project in the last 5 years in the Muscat distribution company. We already reached something around 8 mega projects right now, with almost 85 projects connected, and we are expecting even up to 70 mega in the coming 2 years. And the numbers is increasing very fast because distribution solar systems actually the full project can be conducted in a few months. So everything can be changed very fast. And how exactly the solar system actually affect the distribution networks? Actually, the solar system is offsetting the demand of the consumer. So the impact or the effect actually it will be showing through the RUD, the energy consumption, and also in the peak of the primary substation. As you can see here on the right, as you can see here, there is 2 processes actually we are using right now to estimate the forecast for the solar system in the coming years. This every one of them we are using some inputs from MEDC solar system, and we have also some assumption we need to make. This assumption actually we made it with from MEDC experience and from seeing the GCC countries. So the impact, as I told you, that the impact of solar system will be showing very clearly in the RUD. Now, what exactly the assumption is actually used? The main 2 assumption right now is the solar capacity factor. We are using 20%, 20.5, and solar PV contribution to peak demand, 87%. There is other things like average capacity of installation type, how much right now? Actually, we have for the residential or domestic, we have almost 12 kilowatt peak, and for non-domestic or almost 350 kilowatt. How much actually these systems actually contribute to the distribution network is here. Is almost 10.3 for domestic, and non-domestic we are talking about 300 kilowatt for each solar system. This is the average systems. Now, this is the forecast what we actually see right now and what we expect coming years. We are expecting like in 2028 we will be with the solar application or the connected solar system. It will be around from 120 mega to up to from 80 to 120, and the most of them will be non-domestic connected. We also take in consideration non-domestic. We have a lot of projects coming in the residential, and still the almost all the projects in the residential always it will be a small scale, small size, 10 kilowatt to 15 kilowatt. So this is for solar system. Now, what about the electrical vehicles? As you understand and as you are all aware, the electrical vehicle is coming very fast right now. The ABSR actually said that by end of this year the official regulation will be coming. The current cost even of the electrical cars start going down. Right now we are talking about 15,000 Riyal Omani, which is a good incentive that to go to electrical cars. Right now a lot of pumping station, offices, malls, you can see the charging EV chargers already there. And how actually we can see the effect of electrical vehicle on the demand systems. Right now we are seeing the effect of them immediately, that it will be increasing the energy consumption in RUD and the peak demand. As you can see here, the main input first for this process is actually the 2 main. This is ROP and some EV charger suppliers here in Oman, and we start gathering. MEDC actually doing a lot of work monitoring the network and asking and keep trying to update their data, because we need to understand the actual numbers inside. Right now we are talking in numbers in electrical vehicle around 100 car right now currently of this year. We are expecting the number will be increasing in the coming years. Maybe we'll reach, I would say we can double it by next year. Once the regulation will be out, I think the number will be increasing more. Okay, how we can actually assess the impact of electrical vehicle? We can assess the electrical vehicle by actually taking assumption of the average charge of efficiency for each one car, kilometer per kilowatt hour, and the average gurney every day. And we need to understand that then from there we can actually calculate how much the annual demand of these electrical cars. From there we can understand, and we can then later on we can multiply it by the number of the cars, and we can more and more try to guess how much the contribution to the demand system, to the MEDC distribution network. So this is right now the assumption what we have. We have 5% average efficiency charge. This is we compare it to the GCC countries. We have 100 kilometers every day, every journey, and we have average daily energy requirement almost 20 kilowatt hour. So when we multiplied all this, we got something around 7,300 or 7.3 megawatt hour per year for each car. And of course, the charging time is also important. When you are charging, if you are charging at the morning time is different than evening time. Most of electrical car, for example, for residential, they are charging at night time. So it's very important for us to understand when the time of charging. If night time is much better than the morning time for the distribution network, because the peak is always at the morning, at the afternoon time. So this is our forecast. This is the first forecast that we already started doing. Yeah, we are expecting something around from 400 to 1,200 for the EV cars in the coming, let's say, 6 to 8 years. But this is, of course, can be changed very easy. Can be changed with the regulation, with the price of the electrical vehicles, with the initiative, government initiative is something coming that will be very helpful and can very easily, rapidly increase the distribution of electrical vehicles. Energy efficiency also important for us, and energy efficiency actually can be calculated by the ratio of the RUD per customer account. The consumption per customer. If the ratio keep decreasing with time, for sure it will be showing that the energy efficiency much increasing. Right now in the energy efficiency improvement, still we are not showing an optimistic numbers. We are hoping in the next few years some big improvement in this area. Last thing, which is battery storage. Battery storage, actually right now we don't have that much battery storage that can be contributed to the distribution network. The number is small, or you can say is very minor. We don't have that much projects coming, and even if it's coming, the numbers is very small, and for now the energy storage is not in our head to start forecasting. Maybe in future, maybe this is coming, and we are expecting a lot of energy storage options will come, but for now is not a real choice or option right now. This is my quick presentation. I hope I'm not boring you, but I try my best to keep it simple, try to give you the last updates, and I'm ready if you have any question.
Thank you.